I did my video on imaginary numbers. The basis for imaginary numbers is that I is equal to the square root of -1. By accepting that the square root of -1 exists, we can solve problems that require the square root of a negative number. For example, the square root of -9 is the equivalent of the square root of 9 times the square root of -1, which is I. And the square root of 9 is 3, and the square root of -1 is I, so that means that it turns into 3 times I, and 3 times I is 3I. An example in the real world that we could use imaginary numbers for is alternating current, or AC. Electricity changes between positive and negative in charge in what is called a sine wave. When combined, two AC currents may not match, and it is difficult to find the new current. Using imaginary numbers may make finding the new current much easier. Also, you can use when you're using the quadratic formula, you can find the square root of negative numbers. So, I to the first power is I, obviously, because that's I times 1, and anything to the times 1 is I. I to the second power is negative I, because the square root of -1 squared, well, the square root and the squared cancel each other out, so that means it's just -1. I to the third power is equal to -I, because I squared, which is -1, times the square root of -1 is equal to -I, because that comes out to negative square root of -I, or negative square root of -1, sorry. I to the fourth power is equal to 1, because of our last one, I to the third power, is the negative square root of -1, and that is times the square root of -1. So it's kind of like a negative number times a positive number. It's 1. So this pattern continues to any answer that comes out as I to the x power. You can divide by 4 and use the remainder to find your answer. For example, I to the 23rd power is, 24 divided by 3 is 5 with a remainder of 3. And we only use the remainder because so it becomes I to the third power, and I to the third power is -I. So according to the key above, we prove that I to the third power is equal to -I, or the negative square root of -1. So I want you guys to pause the video and try out the following problem. First of all, I to the 50th power is, when we divide 50 by 4, that is 12 with a remainder of 2. And that is simplified to I to the second power, so I to the second power is equal to -1. On the next one is I to the 1000th power, and 1000 is divisible by 4 evenly, so that would be I to the 4th, and I to the 4th is equal to 1. The next is I to the 7th, and I to the 7th divided by 4 is equal to 1 with a remainder of 3, so that's simplified to I with the remainder, I to the power of 3, and that is equal to -I. And the next is I to the 81st power, and 80 is divisible by 4, and that leaves us a remainder of 1, and I to the first power. Final 4, it was something different, and it was the square root of a negative number. For these, I just stuck with perfect squares so that you could do it without a calculator. So this is the square root of -25, and that is the equivalent of the square root of 25 times the square root of -1. The square root of 25 is 5, and the square root of -1 is I. So that means it's 5 times I, which is 5I. For the next one is the square root of -9, and the square root of -9 is the equivalent of the square root of 9 times the square root of -1, and the square root of 9 is 3, so, and the square root of -1 is I, so that's 3 times I, which is 3I. Next we have the square root of negative 81, which is the equivalent of the square root of 81 times the square root of negative 1. And the square root of 81 is 9, and the square root of negative 1 is I, and 9 times I is 9I. And finally, we have the square root of negative 16, and the square root of negative 16 is the equivalent of the square root of 16 times the square root of negative 1. The square root of 16 is 4, and the square root of negative 1 is I, and 4 times I is 4I.